Hey guys, so um, I've already put up the first lesson of the I guess the new material from after March break. So that was Laws of Logarithms Part 2. Miss Bradley had pre-recorded a lesson for solving exponential equations with logarithms, so I'm just going to leave hers up there and I'll upload that to the YouTube channel as well. And now I'm going to start to go through, so this is the third lesson in the material from last week called Solving Logarithmic Equations Day 1. This is Solving Logarithmic Equations Day 1. First question is talking about why are there no solutions to log base 5 negative 125 equals x and log base negative 2 of 18 equals x. So we'll start off looking at this equation here. And so if we rewrite, so log base 5 of negative 125 equals x, if we rewrite that in exponential form, the 5 here is the base of our exponent. This x is our exponent. And so 5 to the power of x is going to equal negative 125. And the reason we can't do this is we have a positive 5. No matter what exponent we put here, if we put a fractional exponent, if we put a positive exponent, if we put a negative exponent, we're always going to end up with a positive number. So we can't multiply a positive number by itself. And get a negative number. Even if that, remember that exponents, if they're negative, that really just means it's like 1 over 5 to the power of the positive exponent. So that's still going to keep that number positive. That can never give us a negative number. So that's looking at this first equation. Now the second equation was log to the negative 2 of 18 equals x. So log the negative 2, log base negative 2 of 18 equals x. We'll turn that into exponential form as well, because that's what we're a little more familiar looking with. So negative 2 is our base, x is our exponent, and we get 18 here. So yes, with our whole number exponents, we have x equals 1, x equals 2, x equals 3. It's alternating between a negative and a positive. So for instance, if we looked at negative 2 to the power of 4, that would give us a positive 16. If we looked at negative 2 to the power of 5, that gives us negative 32. If we try to go in between that, negative 2 to the 4.5, do I have my calculator here? I do not. So I jumped ahead a little bit because I had to go grab my calculator in order to show you. If we put -2 to the power of 4.5 in our calculator, we get an error. It's undefined. We get a math error, and that's because, so if we put in a decimal in the exponent, that's really like a fraction in the exponent, and that's when we had square roots and other types of roots in there. And anytime we have an even root of a negative, we're not able to take that. We can't take the square root of a negative number. So we get some messiness in there. So because we have a negative in the base of our exponent, we can only trust it to take whole roots and get an actual defined answer back. So that is that first question. Let's see, we have things we need to remember. So it talks about, let's see, so f of x, things to remember. F of x equals log base b of x b does not equal 1, and b has to be greater than 0. X also needs to be greater than 0. So we don't want a base to be 1, because any exponent, this is the base of our exponent again, any exponent 1 is just going to still give us 1. We need the base to be greater than 0, as we saw in this first example here. Sorry, in the second example. And in the first example, it's telling us that the argument of that logarithm has to be greater than 0 as well. So in order to take a logarithm, we need the argument. The argument has to be positive. So greater than 0. And the base, no negatives, no 0, and it can't be 1. So it just has that extra condition. Without solving the equation, state the restrictions on the variable x in the following equation. So we're not going to solve this one. We're just going to look at what this equation tells us. So log of 2x minus 5 minus log of x minus 3 equals 5. So what is this restricting? Because there's no base of the logarithm explicitly told to us, that base is 10. These are both log base 10 logarithms. So we only have to look at the argument, and the argument always has to be greater than 0. So 2x minus 5, that has to be greater than 0. And we can use what we've learned before, inequalities, to solve that inequality. So we move the negative 5 over, becomes positive 5, divide both sides by 2, and we get x has to be greater than 5 over 2, or x has to be greater than 2.5. And we do the same thing with our other logarithm. So log of x minus 3. X minus 3 is the argument. That has to be greater than 0, which means x has to be greater than 3. So x has to be greater than 2.5, and x has to be greater than 3. we put those on a number line. 0, 1, 2, 3. X is greater than 2.5. So we use an open circle. Has to be greater than 2.5. Then X has to be greater than 3. The only place where both those are true is if we have to be greater than 3. I hope that shows up a little bit differently than the blue pen. I don't know where all my red pens are or other colors. But yes, the only place where they're both true is if X is greater than 3. So for both arguments, so back to pen. For both arguments to be true, we would state it as X is an element of R in set notation such that X is greater than 3. And this is a restriction. This is not necessarily what the solution to this equation is. All we know is that our solution has to be greater than 3. And we'll look a little bit later in how we actually solve these equations. So we'll start a new page here. And we'll start off with what we're going to call type 1 logarithmic equations. And those are going to be ones that look like log with some base b of a equals some number. So we always want to simplify to this form. And then as long as if this is our unknown, we can just use the change of base that we talked about, or that I talked about in the last video. But if we're looking for either the A or the B, we're going to change it to exponential form and solve. So first example, log base x of 0.04 equals -2. Already we're simplified to this form here. We have a base, we have an argument, and we have an exponent that once we turn into exponential form becomes the exponent. So if we change to exponential form, we're going to get, so the x is our base, -2 becomes our exponent, and that all equals 0.04, the argument for our logarithm. We're going to rewrite this just as a fraction. 0.04, that's 4 hundredths. So this is the same as 4 over 100. Or if we simplify, we get 1 over 25. 1 over 25 is 1 over 5 squared, which is the same as, sorry, this was -2. So x to the -2 equals 5 to the -2. We get rid of that fraction there. So bring the 5 up, becomes a negative exponent. If x to the -2 equals 5 to the -2, the only way that can be true is if the x and the 5 are the exact same thing. So x equals 5. that one we got relatively lucky, works out quite nicely. Sometimes it won't always work out quite so nicely. So let's look at another example here. So example 2, we have log of x plus log of x squared equals 12. Our product rule that we had talked about in previous lessons, if we have two logs with the same base, so there's no base listed, it's base 10, same base, and they're added together, it's the same as writing them in one single log multiplied. So we can multiply the arguments of those two logs and combine them to create just one log, and that gives us log of x cubed equals 12. So we get it to that one single logarithm, the form we're looking for up here, and now we can change it to exponential form. So if we change it to exponential form, remember our base, when it's not listed, the base of the logarithm is 10. 10 to the power of 12 is going to equal x to the 3. 10 to the power of 12 is x to the power of 3. There's no, actually that's a lie. Don't listen to what I was about to say. So 10 to the power of 12 equals x cubed. The easiest way to get just down to a single x is if we have something cubed, we can go to a power of 1/3 to counteract that. So we'll put both sides to the power of 1/3. X cubed, power to a power, we multiply 3 times 1/3, just gives us x, cancels out. 10 to the 12 to the 1/3, 12 times 1/3 is 4. So this is, x is just 10 to the power of 4. So x has to equal 1,000. Another way that we could have looked at this, when we were at this stage, when we had log of x cubed equals 12, is we could use the power rule for logarithms, where if we have an exponent in our argument, we can bring that out front, and we get 3 log x equals 12. Because this 3 is multiplied by the log x, we can divide both sides by 3. So 12 divided by 3 gives us 4. And then we can rewrite into an exponential form there. So again, no base means base 10. 10 to the power of 4 equals x. Oh, that gives us our answer almost right away. 1,000 equals x. So we get the same answer either way. 2 different ways to look at it. That's it for that first side of the page. Let's look at another example. Number 3 is log base 6 of x plus log base 6 of x plus 1 equals 1. So same thing as before, we have 2 different logs. We want to get it to the form where we just have one single log. So we can use product rule to combine those logs. So we have the products of those 2 arguments in a single log, and all of that equals 1. And we can multiply that out. Log base 6 of x squared plus x equals 1. Moving to our exponential form, we have base 6, exponent 1, and then the argument is on the other side. So 6 to the power of 1 equals x squared plus x. Well, 6 to the power of 1 is just 6. And now we really just have quadratic. So we can move everything over to one side. X squared plus x minus 6. We factor that out. X plus 3 times x minus 2 equals 0. And then from here we get an x equals negative 3. And we get an x equals 2. But we have to remember, look back at our arguments. So we should have done this before and look if this makes sense. In these two, here we had a 5 in our base. That's okay. Here we had 1,000 in our argument, and this would be 1,000,000 in this argument. That's okay. Here, negative 3, we can't have a negative 3 in this argument. So we can't have, because we can't have a negative argument, this answer is inadmissible. It doesn't make any sense. X equals 2, if we plug that in, that's fine. So that's going to be our only solution to this one. So even though we had a quadratic that gave us 2 solutions, only one of the solutions is valid for this question. We got one more for equations for this type. So example number 4. Log base 2 of x plus 3 plus log base 2 of x minus 3 equals 4. So again, we can use product rule to combine those into a single log. So we get log base 2 of x plus 3 times the other argument, x minus 3. All of that is going to equal 4. If we have it to a single log, we can move it to exponential form. 2 is our base. Our exponent is 4 equals the arguments, x plus 3, argument, x plus 3 times x minus 3. 2 times 4. 2 to the power of 4. 2 times 2 times 2 times 2 gives us 16. Here we have a difference of squares. So we get x squared minus 9 if we expand that. And then there's kind of 2 different ways we can look at it. We can bring everything over, or bring like terms to each side. So we have our x squared on one side. If we bring that negative 9 over, it becomes a positive 9. 16 gives us 25. X squared equals 25. So x is the positive or negative square root of that. Positive or negative 5. And because we can't have a negative 5 in our arguments, it's going to give us negative arguments. That's going to be inadmissible. So it's just positive 5 that will work out. Or we bring everything over to one side. We would get 0 equals x squared minus 25. Again, we have a difference of squares. And so we'll get 2 different answers. We'll get x equals positive 5. We'll get x equals negative 5. Again, that -5 doesn't make sense, and we just get x equals 5. So 2 different ways you can think about it. Again, either way gives you the exact same answers, so whatever you feel more comfortable with. So those are four types of equations where we have a single log equaling some number. The other possibility is we could have, so log equation type 2, we might have some log equals some other log with the exact same base. So we're going to simplify all these questions. So we're going to simplify each side of the equation to a single logarithm first. And then, if the bases match, so if we have that exact same base on both sides, then we can make the two arguments equal to each other. We can equate the arguments of the logarithms. So first off, we'll look at example number 5. Log base 2 of 30x minus log base 2 of 5 equals log base 2 of 12. So first step, we want one log on each side. Here we have 2 logs. They're being subtracted, so we can use quotient rule. So we will get log base 2, and we divide our arguments of 30x divided by 5 equals log base 2 of 12. If we divide that out, log base 2 of 6x equals log base 2 of 12. So we have one single logarithm on each side. Our bases match. We have base 2, so now we can make our arguments equal to each other. So our argument here, we have 6x. Our argument here, we have 12. 6x equals 12, divide both sides by 6, and we get x equals 2. Does x equals 2 make sense? This is the only part where x comes in. 30 times 2, positive number. Bingo. We're good. Example number 6. 2 times log x equals log 8 plus log 2. If we have a number multiplied out in front, we can bring that over as the exponent. We get log x squared. And then to combine these two logs, we can use our product rule. So we're going to multiply our two arguments together. So that gives us log x squared equals log 16. So we have one single log on each side. Our bases are the same. We don't have any bases written down, so that means that these are both base 10. So log base 10 of x squared equals log base 10 of 16. That can only work if the arguments are the same. So x squared has to equal 16. So take the square root of both sides. and we get x is either 4 or -4. We can't have -4. That's inadmissible. It means it's an answer that pops out, but it would fall into one of our restrictions where here x has to be greater than 0. So we just get left with x equals 4. Just a reminder, if you have any questions on specific questions, you can email me, you can post a comment on the YouTube video, you can write a message in the Google Classroom. There's that Google Hangout I set up. You can message the Advanced Functions Group 1 or privately to me. Any questions you have, please let me know, and I can address specific videos or just type up a response depending on what the question is. But there are a number of ways you can contact me, and definitely let me know if you have any questions. So we have 2 more examples on here. Example 7. Log base 8 of 2 minus x equals 1 minus log base 8 of 4 minus x. Okay, so we want to combine everything into a single log on each side. The problem is we just have the number 1. We don't have a log here. We know from experience, hopefully by now, that in order to combine things, we would like to have logs with the same base. So we can rewrite that 1 as a log base 8. And so what this is, if we're seeing what is log base 8 of something equals 1, 8 to the power of 1 equals that something we're looking for. 8 to the power of 1 is just 8. So log base 8 of 8, that's the same as 1. So we can use that trick in order to get 2 logs with the same base. And now that we've done that, we can combine them using the quotient rule because we're subtracting here. So log base 8 of 2 minus x equals log base 8 of 8 over 4 minus x. We have the same bases. We have 1 log on each side. So 2 minus x equals 8 over 4 minus x. So now we have a rational equation. So we're going back to last unit in order to solve these. Because it's an equation, not an inequality, we can just multiply out that denominator. So we're going to have 4 minus x times 2 minus x equals 8. Can expand this out. 4 times 2 is 8. 4 times negative x, we get negative 4x. Negative x times 2, we get negative 2x. So combined, those give us negative 6x. And negative x times negative x plus x squared. All of that equals 8. So those 8s, they're going to cancel out. If we move that over, it becomes a negative 8. We just get left with x squared minus 6x equals 0. So we can factor this. We have an x in both terms. We get left with x minus 6. And so we're going to get x equals 0 and x equals 6. So let's look back at our original question. 0, that works out, that's positive. That works out, that's positive. So x equals 0 is a solution. X equals 6. 2 minus 6, we get negative 4. That means that this is inadmissible. We get a negative argument. That's no good. So just x equals 0 is a solution for that one. And one more question, example 8. Log base 5 of 2x plus 2 minus log base 5 of x minus 1 equals log base 5 of x plus 1. Two logs, same base. We can combine them using quotient rule because we're subtracting. Log base 5 of 2x plus 2 over x minus 1 is going to equal log base 5 of x plus 1. Now we're done that first step. We have a single log on each side. They have the same base, so we can make those arguments equal each other. Don't need brackets anymore. 2x plus 2 times x minus 1 equals x plus 1. Again, it's an equation, so we can just multiply both sides by that denominator. So the left side, it cancels out. The right side, I'm looking at the wrong term. Sorry, this is x minus 1 that we're multiplying by. X plus 1 times x minus 1 is going to give us x squared minus 1 equals 2x plus 2. You can bring everything over to one side. So x squared, subtract 2x, subtract that 2, we get negative 3 equals 0. And if we factor this out, that equals 0. So we get an x equals 3 and x equals negative 1. Again, we want to look, are these valid? X equals 3. We're okay there. We're okay there. We're okay there. It's positive in all of them. We just need the argument to be positive. So that's good. X equals negative 1. Oh, here we get 0. Here we get 0. Here we get negative 2. Here we get 0. None of those are okay. So this one is invalid, inadmissible. We get a negative or 0 argument. All of those things are bad. So that's some examples on how to solve logarithmic equations. Again, all I'm expecting you to do right now is attempt the homework questions. Ideally, I want you to do the homework, and that'll help make sure that you're keeping on top of the work. And for those of you who need this material for next year, you're entering university in a good spot. Please, please, please let me know if there's any questions from the lessons or the homework. I guess this will probably be up after I record the next couple lessons, but I'm going to keep recording lessons today and try to catch up as much as I can so that we can focus on moving forward. Hope all is well with all of you. Stay tuned. There will be an assignment at some point next week wrapping up this unit. And don't stop asking me questions. All right.